Good day, grade 8s. I'm Ms. Babo, and today's lesson we are going to be looking at series and parallel circuits. For this section, we are going to look at what is the difference between series circuits and parallel circuits. As you can see in the two diagrams provided, a series circuit provides only one pathway for the current to pass through, and a parallel circuit will be able to supply multiple pathways for the current to pass through. So let's start looking at a series circuit. In a series circuit, there is only one pathway for the current to flow in. This means that the current will start at one point and flow through one pathway and continue flowing until we switch it off. In a series circuit, the current will be the same strength everywhere, as there is only one pathway that the current can flow through. In series, the more resistors we connect, the higher the resistance. This is again due to there only being one pathway for the current to flow in. So if we add more resistors like light bulbs or resistors in general, the higher the resistance will be of the series circuit. In a series circuit, because there is only one pathway, we only need one switch that will control the circuit. So if we switch the switch on, the current will flow. If we switch it off, the entire circuit's current will stop flowing. In series, if there is a faulty device, which means a device that will not work, or a light bulb that is blown, or a broken device, it causes the entire circuit to stop flowing. An example that we can see here is in Christmas lights. If a single light bulb does not work, the rest of the light bulbs will not work either, due to there only being one pathway. And lastly, in a series circuit, the more light bulbs we add in series, the less brightness of each bulb, as there is only the current supplied to the entire circuit that flows through those light bulbs. Now, in parallel circuits, the first thing we're looking at is that there is more than one pathway for the current to flow in. As you can see on the two diagrams on the left, there are multiple pathways for the current to flow through. The current will divide at the different branches of the circuit. So it'll flow together, and when it reaches the division, it will divide between those two branches and continue flowing. In parallel, the more resistors we have, the lower the resistance, because of the different pathways where the resistors could be placed. In parallel, unlike series, each pathway can be controlled by a separate switch. This is due to the current that flows through those pathways, that it can continue working. If one device is switched off in one pathway, the other device in a different pathway could continue working. In parallel, if there is a faulty device, the current still works, and this is due to the different pathways that can be found in a parallel circuit. An example where we can see a parallel circuit is usually in our houses. Our house works on a parallel circuit, as if we switch the lights off in one room, another room we can switch the lights on, and there will be no effect on one another. So houses are an example of parallel circuits. And lastly, the more light bulbs we have in parallel, the brighter they will shine, due to them getting the current from each pathway. If we have a look at two examples of series and parallel, the example on the left-hand side is a series diagram, or a series circuit. As you can see, there is only one pathway for the current to flow in. But the diagram on the right-hand side is a parallel circuit. As you can see there, the pathway will split into two different pathways, each leading to a light bulb, and afterwards it joins back again to join into one pathway. So this is a series circuit on the left-hand side and a parallel circuit on the right-hand side. If we were to ask you to draw a circuit, this would be the outcome of your circuit. On the left-hand side, we have a series circuit, and on the right-hand side, we have a parallel circuit. This is how you would represent a series or parallel circuit if asked to draw a circuit diagram. Now, let's have a look at how to draw circuits. What you must remember when drawing a circuit is to always follow the given instructions. So our instruction to you is to draw a circuit made up of two cells, an open switch, and two light bulbs in series. So First thing, easy way to remember is to draw what's given to you first. Remember, the components can be placed anywhere in the circuit, but an easy way to remember is to follow the given instructions. So, number 1, we've asked you to draw 2 cells. 2 cells make up a battery. Next thing is to draw an open switch. So, step 2 would to carry on the drawing, but include an open switch. Step 3, to complete the circuit, there is still 2 light bulbs in series. So what we have done here, we've continued drawing down to make our conducting wire on the right hand side, and at the bottom we've included our 2 light bulbs to make a closed circuit. Last bit for this section is output devices. Now, an output device is any device that would use electric energy to provide a certain function like light or sound or a buzzer due to the energy conversion of the electrical energy. So some examples here could be an LED bulb or a light bulb or a speaker or buzzers, and they are all output devices as they are giving off the conversion of electrical energy. Thank you for coming to my lesson. We'll see you for the next one.